and welcome. You should be on page 49 of your pre-algebra quarter 2 notebook. In this video, we are going to practice identifying slope and the y-intercept. So this equation, y equals 2x plus 1, can be represented here in this graph. That is what this equation looks like as a graph. So in previous lessons, we would have used a table of values, found domain values or x values, plotted some points, and made our line. Well, let's take a look at another way that we can begin to think about graphing lines. First thing I want to find is the slope. If you remember in our last video, slope is represented by the variable m, and it is the change in y, or the vertical change, over the change in x, or the horizontal change. We can also refer to slope as the rate of change. If I'm looking left to right, I see that this is a positive slope. So let's find out what the slope is. If my slope is the change in y over the change in x, I'm predicting a positive slope. I'm going to go up 2, so my change in y is 2. And I go right 1, both positive numbers, 1. And if I simplify that, 2 divided by 1, fractions are division, is 2. And my slope is 2. Now we need to think about another concept, and that is the concept of the y-intercept. In algebra, we call the y-intercept b. We use the variable b to represent the y-intercept. And b can be found on a graph as it is where a line crosses the y-axis. And I like that because it's the y-intercept and it crosses the y-axis. So let's take a look at this line. This line crosses here, and that is at 1. So in this case, this line crosses when y equals 1. So b equals 1. If I take a look at this equation now, y equals 2x plus 1, I notice that my 2 is m, and my b is here at the 1. And that brings us to the slope-intercept format. Slope-intercept format is y equals m, or the rate of change, the slope, times your x value, plus your y-intercept, or b. Let's take a look, and our first order of business is to practice identifying slope and y-intercept. Eventually, we're going to use the idea of slope and y-intercept to graph lines. So it's going to be an alternative to using table of values. We are going to first identify the slope and y-intercept for each equation. In order to do that efficiently, our equation should be written in slope-intercept format, which is, of course, y equals mx plus b. Is this equation in y equals mx plus b? Yes. So I know that this is y equals mx plus b. So my m, or my slope, is negative 1/3, and my b is a positive 2. Let's look at our next equation. Y equals mx plus b. Well, I can see my m. M equals negative 3. But there's nothing there for b, is there? So what number could I write to represent adding nothing? Well, I could add 0, and that is my b. When there is no b clearly there, it equals 0. And what this tells me is this line crosses through the origin. Let's look at this one. This is y equals 2. I don't know if you're remembering from our previous unit, but when I have a y equals a number, that is going to result in a horizontal line. And if you think about it, if y equals 2, remember we would fill in the table of values. sorry, I'm going to look this up a little. We would fill in the table of values with 2, 2, 2, 2, 2 at y. So y would be 2, 2, 2, 2, 2, 2, all the way across, resulting in a horizontal line. So y equals 2 results in a horizontal line. Let's just think about y equals mx plus b. Well, there's no mx, is there? I don't have a number times another number. So m in horizontal lines are 0 because x values can be anything, because 0 times anything is 0. And b, this will cross the y-axis at 2. Okay, if I look at number 4, it is not an mx plus b, y equals mx plus b, or slope-intercept format. So I'm going to use a little stay and go. Remember, I want y to be isolated. We called it function format. So this is going to go, remember that's a 1, so it's going to go over as negative 1x. This will stay positive, and this will stay as minus 4. So my y equals mx plus b equation is y equals negative x minus 4. Now I want to remember that if there's no number there, that's really a 1. And that's very helpful because when I think of y equals mx plus b, if there's nothing there, my slope is either 1, or in this case, I forgot to write my m, I would be negative 1, and my b is negative 4. Okay, let's continue on to page 50, and we're still looking at determining our x and y, our slope and our y-intercept. So in this case, we're going to identify our slope and our y-intercept on a graph. So remember that the slope is the change in y over the change in x. And my y-intercept, or b, is where a line crosses the y-axis. So b for me is always easiest to identify. Here's where it's crossing the y-axis. Looks like negative 1, negative 2. Let's look at my slope. M equals the change in y over the change in x. Looks like it's going to be a positive slope, and I'm going to go up 1, 2. So that's a positive 2. Over to the right, 1, 2, 3. I can't simplify 2/3, and it looks like my slope is 2/3. Alrighty, let's take a look at number 6. This looks like a negative slope, so I'm anticipating something negative. I don't have any perfect points, but I can see that I'm crossing the y-axis to find my b right there, and that's at b equals 1. And then I'm going to try to find another perfect point, and I see one right here. And I know that my slope is the change in y over the change in x. Looks like I'm going down 2, which is my negative 2, and to the right 1, positive 1. Negative 2 divided by 1 is negative 2, and my slope of this line is negative 2. Okay, we're going to end our identifying M and B journey by looking at table of values to identify the slope and y-intercept. In this case, we are going to have to go back to our formula. Our slope equals the change in y over the change in x always, but we're going to use the y2 minus y1 over x2 minus x1 formula to find the actual slope, because we don't have a graph to use. Now, I also don't have a graph to use. Where does it cross the y-axis? Well, when we look at a graph, I can see that whenever I cross the y-axis, x equals 0, right? It doesn't go left or right. So b equals the value of y when x equals 0. So you're looking for x equals 0. That will give you your y-intercept. So let's take a look at these tables of values and see what we can make of them. First thing I'm going to look for is my y-intercept. I'm looking for x equals 0. Here it is, right? X column, x equals 0. y equals 9. That's B. Now I need to find my slope. So I'm going to use these 2 points. I'm going to write 6, 7, and 3, 8. I like to label my points. Sorry, why? Sugar plum fairy. Excuse me. What I'm doing here. X1, Y1, X2, Y2. Let's fill in my formula. Change in Y over the change in X. That's 8 minus 7, and it's 3 minus 6. If I put that in a calculator, I know that 8 minus 7 is 1. 3 minus 6 is negative 3. I can put that into Desmos or in a calculator. So my slope is negative 1/3. All right, let's take a look at our next one. I am realizing that y is the same. I'm not sure if you remember what that means, but as you know, when y is the same, that is going to be a horizontal line. So that's just something to start looking for. But before I even do that, where is x 0? I'm looking for my b. X is 0 at y equals 5. So that's b. Let's find my slope. I can use any 2 points. Let's just use these 2. 4, 5, 6, 5, x1, y1, x2, y2. And just a thought, if all of my y's are the same, I have a horizontal line. I am predicting that I will calculate, knowing that it's a horizontal line, that my slope will equal 0. But let's make sure that is the case. Change in y over the change in x. I have 5 minus 5 over 6 minus 2. 5 minus 5 does indeed equal 0. I've got 0 in the numerator over 2. My slope is 0. So my prediction, horizontal line, was correct. That's all for this video. Thank you so much for listening.